where we are offering you many important content. So everybody talks about Ethereum merge on the many sites. So today we are together with Mario Havel, one of the names of our community has met before in ETH Prague. He was a part of Ethereum Foundation and continued as a part of the work in the merge process. So I want to share a little bit background of the we are met in when we went to the ETH Prague hackathon before we met at Parallel Nepolis in a hackers in Prague. It was a really enjoyable and well days, 3 days for us. So we are so happy to meet with you. First of all, thanks so much for coming to share your time with us. So how are you? Is everything all right in your life? What are you?
Yeah, thank you so
Where are
much
you
for
doing
having
right
me.
now? What you doing?
Yeah, so thank you so much for having me. It's as you said, like it was a really pleasure to meet you folks during ETH Prague. It was fun. It was a great experience there, and I'm doing well. I'm getting ready for the merge. I mean, it's a bit stressful this week. I mean, there is a lot of stuff to finish before the merge, but on the other hand, there is many things to look forward to. So I'm excited, and I'm excited to share this with you today.
Okay, sounds great. Well, for, I want to ask before your presentation. Is there anything changed to the last day of the merge? Like you can you take any book bounty or the other things that to the merge? Is there any problem
Actually,
these days?
so like what you do these last days of the before the merge, right? Like that's what before the merge till it happens, like for these like past 2 weeks, the bug bounties for the security vulnerabilities in clients and for like possible consensus failures and so on were tripled or even more. It's maybe like 4 times the original sum, so you can earn like nice money if you find some important vulnerability during these days. So if you're a security researcher, if you are just a programmer, maybe just looking to what is happening in the clients, verify the testing scenarios, and if there is some critical bug these days, it would be really good to find it before the merge, of course. But there is a last shadow fork. There was many. I will explain in my presentation, but there was a lot of testing happening, and the last shadow fork is actually happening these days. So I believe that we're mostly good, and what you can do as a individual is to run a node and participate in the merge to see it live, to have your computer to experience it. And I'll talk about it in the presentation. I'll show you how to get into that.
Oh, okay. Thank you so much coming again. So maybe we can start your presentation.
Oh yeah, let me share my screen. And yeah. Okay, good. Let's get into it. So thank you so much again, folks, for having me, for organizing this. I mean, I really appreciate that there is a community like yours which focuses on these topics. And so let me know if you can share my screen, if it's all right.
Yes, we can see.
Cool. So yeah, as the name suggests, I will talk about the merge, but not just that. Actually, I would like to talk about how Ethereum 2.0 all is not happening because the ETH2 meme was dropped a while ago, and some people are still using it. And some I noticed recently that with the merge, some people are expecting that like the merge brings the ETH2 or something. So I want to explain that ETH2 doesn't exist and won't exist, and explain it in the way that we'll look into what is the merge. So like I hope you're not disappointed, because many people over past many years got excited about the E2. Like it was supposed to be the solution for all the world's problems, all the scalability and decentralization and security and so on. And um, and it's been something which was talked about like since the beginning of Ethereum, actually, I would say. And there is this meme that it's never going to happen and it's getting postponed. And now people, probably because of that, are expecting that it's happening over the merge. But there are actually multiple parts to it. And I and people people have some weird expectations. So I would like to explain the merge and set the ground, what is actually happening. And to explain this, we need to ask ourselves question: what is actually Ethereum? So I don't know if we have some input from the audience, but if there, or if you folks are listening, just give me some answer. Like, what is Ethereum? It's a platform. It's a cryptocurrency. Ethereum is love. Well, how would you define Ethereum?
I think I define as ecosystem.
Okay, cool.
Yeah, also
Um,
community. Yeah.
Nice, nice. I like to see that you are coming from like the social cause as well. Like, it's not just technology, right? And but now, I mean, we are speaking about a merge, about the purely technological aspect. So within the technology, within the Ethereum itself, like the core, the heart, the brain of the Ethereum, what I would call is the EVM, or the Ethereum virtual machine. So one answer to the what is Ethereum technically this time could be that it's mostly EVM, or like one of the most important parts to Ethereum is the EVM. Now this is the execution environment. This is the virtual machine which actually runs all the contracts, all the programs. So Ethereum is a platform which doesn't enable just transactions, or like just transacting in changing numbers in database, but it's this database actually a result of a complex programs which are executed, run in this EVM environment. And so this EVM has creates the data based on the outcome of the execution. We call this data state. The state is basically a database of Ethereum. It records state, or accounts for all the accounts, all the contracts, and their what all the data about them, or how much money they have, and their source code, basically, or bytecode. So EVM executes based on state, and how do we trigger this execution is with transactions, right? So you send a transaction, it gets executed in the EVM, it generates new state, and this transaction get to the network, or like is broadcasted, transferred in the network thanks to its peer-to-peer layer. So Ethereum is a distributed network of many computers running the Ethereum, and they send each other the data over a peer-to-peer communication protocol. And this data, or these transactions need to be somehow verified. They are verified by the EVM execution itself, but to decide which become part of the blockchain, we need some consensus. We need to agree how the blockchain will continue, and this is provided by the consensus mechanism, which is proof of work. So this is Ethereum. This is my answer to what is Ethereum. Very, very simplified. And I would divide it to two parts. That we have the execution part here and the consensus part. The execution being the actual data and their execution, and the consensus part, currently it's the miners who provide the proof of work, based on which all the nodes continue the database, the blockchain database, right? So another answer to what is Ethereum would be yellow paper or white paper. Yellow paper is actually specification. It's more technical details. It's technically specified into a detail how Ethereum is supposed to work, but this is already many years all there are some it's not always up to date, and there are missing EIPs. So uh, other parts of the specifications are the EIPs, Ethereum improvement proposals, and altogether it creates the specified version of Ethereum. So we come from some idea to a specification, and now we need to implement it, right? So now we have implementation, the program which does what we have specified in the specification, and there are many of these. uh, the parity and open Ethereum and Trinity, which is the like uh, the thing in the middle down there. the blue one, those are deprecated. Those are not developed anymore. But we have Go Ethereum, Aragon, Nethermind, Besu here, which are the mainnet-ready Ethereum clients. There's also Aquila written in Rust, fairly new client. So these are providing actually everything in this scheme, the execution, and also enforce the consensus. So
Mm.
yeah.
What are the advantages or disadvantage of the having more than one client?
Okay, great question. So, Ethereum approach is a client diversity. To compare this with Bitcoin, for example, the Bitcoin is focusing on, or like the vision of the community in Bitcoin is to have one client, and it kind of comes from the historical background where Satoshi just created Bitcoin, what is now Bitcoin Core, and it never been specified. And there are alternative implementations, but they are almost not nowhere used. I know 1% or something. In Ethereum, it comes, as I explained, the other way. So we have the specification, and based on this, each of us create own implementation. And now this implementation enables client diversity. This various implementation. And what is client diversity is basically that I have it further in the slides, but basically, if we have just part of the network running each client, and there is some issue, some bug in this specific client, the rest of the network it just continues. But if we just have to rely on a single client, that means that whole network would be down. So it gives us more decentralization and more security in a way that like each client or most of the clients they're implemented in a different programming language, which means they use completely different libraries. There is Go, Rust, .NET, Java, and now if there is, for example, some issue in a cryptographic library, because they are using the standard cryptographic libraries of the language. So now if there is some issue with the cryptographic library in Go, it means that all the Go code is now affected by it, but a client in a different language is not. So this language diversity gives us this security, but also it invites more developers. So like if I'm a developer and my preferred language is Rust or Go or whatnot, I have these libraries, this client which I can contribute to, and I can use in my preferred language, right? So yeah, that's the client diversity. That's why we go this way. And this is just the execution clients. I will get into the client diversity even deeper later. But to somehow sum it up, this modularity of Ethereum, which I started before, the execution and consensus layer. So the enforcement of the consensus by the miners and the actual execution, the data layer. I would separate even another one, data availability or data layer, how the data itself is stored, and we can split Ethereum in these modules. The modularity is
Sorry.
yeah.
I want to ask you something before this part.
Yeah.
What's the difference between execution layer and execution part due to this before slides?
Okay. So I will. So the execution. I'm not very technically correct here. I was trying to just before. I'm just trying to explain like which part of the Ethereum we consider the execution, and it's the actual EVM and the verification of each transaction. But technically, we can split it and consider it like different modules, different layers, which is the execution layer, the data layer, the consensus layer. Let's say. So I will explain like what is the difference between, or like where we make the difference between the execution and consensus even more later, or like it's actually here, right? I mean, you can imagine the consensus provided by miners. Yeah, let's say the data is the state, or in current Ethereum it's rollups, because there are some data in rollups which are not published in the Ethereum itself. So there is another data availability layer. So yeah, this is Ethereum, so I want to give you this idea of how the developers look at it in this modularized context. Like the modularity is something which is like basic of software development or like Unix philosophy for 40 years, it's or more. It's not a new thing. Basically, it enables to overcome complexity. It enables us to like by having modules with some clean interface, we can focus on debugging like small part of the code, and which is not affecting the other parts, and and it gives us more security, more versatility in the software. So so this is why I'm explaining it in this modular kind of manner. But it's also because like the Ethereum is getting more modularized on the core. So so yeah, this is the Ethereum. This is what I call Ethereum with all of these things as it looks like today. But what is Ethereum 2.0, or where does it
I have a
come from?
question
Yeah.
before getting into 2.1. I think Ethereum has more modular structure than other chains now. How do you think Ethereum will be more modular, or how will Ethereum expand about modularization?
I will talk to it. It's why I'm getting into the E 2.0 part. And it's actually like, I mean, this modularity, which is not technically abstracted. Like I create this abstraction, this is how it looks like in a different parts of the client, but actually it's still one software right now. Or I mean, not counting the rollups or some mining software, it's actually one thing. And we are modularizing, we are abstracting this into different in its own implementations. There are clients which like even Go Ethereum, the main client is by itself, it's modular. There are has it is modularized. Even Aragon, for example, Silkworm has this approach of being as modular as possible. But now I'm talking about like the core layer, and that it's forced us uh, um, to create this modularity even in a core protocol. And that's actually what Ethereum 2.0 is doing. It's the result of these upgrades. And a few months ago, if you looked at the Ethereum org, it still said that there is E2, and this is what it includes. So it's the beacon chain, the merge, and shard chains. So yeah, let's look into this. Let's look what the beacon chain means first of all. And the beacon chain is, as the name suggests, the chain of beacons. it's it's a coordination layer. It's its own network. So it's a blockchain as its own network, which has been created to implement the new consensus for Ethereum, the proof of stake consensus mechanism. Um, and so this was started, or like the network went live on 1st of December 2020. So it's been running for, well, almost 2 years now. And during this time, it was bootstrapping liquidity. So this network actually implements the proof of stake. There are the actual stakers. They take the real Ether, they lock it into a contract on Ethereum, and based on that, they have the privilege to validate blocks on the beacon chain. And for these almost 2 years, the liquidity was bootstrapping there. So there have been the number of validators was growing, and currently there is like over 14 millions of Ether staked, and which is like over $20 billion. So this is the crypto economic security of the beacon chain, which has been slowly, or like maybe pretty fast actually, aggregating in the network over, well, since December 2020. So now, where is the beacon chain in this little graphics? So what the beacon chain is doing is that in the current data, or in the current state of Ethereum, there are people who submitted their Ether, staked it, or better say, locked it into the deposit contract. So in this contract, people put their 32 Ether to activate one validator, and Now, the beacon chain as the network itself connects to the Ethereum, to the normal Ethereum client, which I described before, the Go Ethereum, the Nethermind Besu, and it checks these contracts, and based on this contract, the deposit contract, it can identify who is the validator or who can validate the chain. So this was the state of Ethereum for almost 2 years now. This is how it's been running with the beacon chain. The beacon chain is basically outside. It's just checking what is happening on the Ethereum, and it's driving who can validate. And now the merge comes, and is the merge. so this is what merge does. You see this arrow. That's everything what the merge is basically. And what does it mean is that the consensus layer, or the consensus of the network of Ethereum, is now not driven by miners, but enforced by the beacon chain. So yeah, the merge. We call it the merge because we are merging two parts. We are merging, well, two networks actually, the beacon chain and the Ethereum mainnet, and we are letting the mainnet be driven, the consensus of the mainnet be driven by the beacon chain. Here is a nice graphics which explain it. What is important here is that, like, you see the execution layer, the historic state, the black arrow stays the same, and just the red and green consensus layer around it changes. So many people imagine that the Ethereum will be shut down and restarted as a different network or something like that. Like, please don't even think about that. We are basically just swapping components here. Yeah, we have different boxes, and they are just changing. That's the beautiful part of it. The merge will happen in a moment when the nodes in the network stop listening to miners and start enforcing the beacon chain rules. Yeah, here is the announcement. And as you can see, it is supposed to happen so there was Bellatrix. The Bellatrix upgrade happened it was upgrade of just the beacon chain network. It happened 2 days ago, very successfully. And now the only thing rest is the Paris, which is the merge, and it's supposed to happen at a predefined terminal total difficulty. I will get into that about the timing of the merge, but to give you the idea what actually happens when this number is reached, when the merge occurs, this is how it looks right now. So we have these basically two blockchains, the current proof of work chain, where you have the execution layer data, the transactions, and each block is referencing the block before, right? That's why it's blockchain, because it's chain of blocks. And the same in the beacon chain. You can see that each block here has the validator data, the signature of the validator, and it's referencing the previous block. So it's chaining the blocks, and they're living in parallel, right, independently. The beacon chain is dependent on the data in the current state of the Ethereum, but they're like basically two networks, and we merge them, right? It's the merge. So they are merged into one network in a way that now it's actually one network with one set of blocks, and this block is referencing, well, the execution data, the transaction data are referencing the previous execution payload, or the block, and the beacon blocks is pointing to the previous beacon chain block. So it's the transaction data are now part of the beacon blocks, and and they become the one network. They become one chain, right? So that's the merge technically. What does it mean practically for users is well, not much actually. Nothing changes for you. The idea of this happening is that it's completely smooth. It's you shouldn't even notice that something happened. Like, you are sending a transaction before the merge, and it gets confirmed after that, and you don't even notice that the merge occurred. And everything just goes on. And this is well, because of the modularity actually. So we had in this schematics, the Ethereum client here is considered as two things: the beacon node, which is driving the consensus, the execution engine, which is the current client, which is only serving the execution, the verification of transactions, and the serving the data. So as a user or a dApp developer, you are using the same RPC, the same whatever Alchemy, Infura, your own node thing you used before. It's the same RPC with basically no changes. But there is another API, the engine API, which drives the communication between the beacon node and the execution engine. And the beacon node or the consensus client also has its own API, but this is only for validators or somebody interested in the beacon chain data. So yeah, this is how the architecture will look like post merge. And this is a photo from the very first merge in the current specification of the engine API. And this is in October last year. So you can see all the classic folks from the core community here: Dankred, Peter, Tim, well, Vitalik, Marius, and yeah, so Vitalik is impressed. Everybody got excited that this is possible almost a year ago now. And since then, it was mostly testing and ironing out all the details. So yeah, we are here after almost a year. It's happening. We are ready to bring the sustainability, the effectiveness, the security, and decentralization to Ethereum. So yeah, let's look into each of these actually. Let's quickly dive into all of these premises of the merge. So first of all, and probably the most discussed is the energy consumption. So what we have is that with to secure the network by proof of work, we have the huge guessing game, and the faster you guess, the better you are. So now there are many people with big machines doing a lot of guessing per second, like trillions and billions and I don't know, sextillions of hashes of the guesses per second. And this takes a lot of energy. This costs a lot of hardware, which is not really effective, not really ecological, I would say, in a sense that, like, the if you imagine the transaction per energy unit it costs, it's well, it's hard to say whether it's worth this, the energy, or whether the security we get is not too much or enough. So there are solutions to this, like on Bitcoin, the Lightning Network, the second layer, which enables like scale many transactions without ever putting them on chain. So it enables us to make effective transactions. In Ethereum, we also have rollups, but we are still scaling within certain limits. And what brings the total effectivity, the ecological effectivity, is the proof of stake. Here is the comparison of how little it would cost to run the proof of stake network, or will cost, and it's just incomparable, right? It's 99.9% less. So yeah, looking forward to that. It's interesting to imagine that, like, by these developers, the people working on the Ethereum proof of stake are are responsible for just deleting so much energy waste that they can, I don't know, fly private jets all their life and they will still not cover it, I guess. Or so that's the sustainability part. Now the security one.
Sorry, I want to ask something about the proof of work energy consumption. I think that proof of work presents the revolutionary structure with Nakamoto consensus in Bitcoin. That's a fact. But do you think that energy problem of proof of work has been discussed since the early days of Ethereum? what was the main purpose of the Dune change the mechanism to proof of stake? Or
I'm getting there. I will
what else?
explain like the more reasons. Like this is so one thing is that like the proof of work works. Like I mean that's the best thing about it. Like it works really well. It's a kind of naive solution which is simple, elegant, and it works well. But it's hard to scale it. It's hard to scale it because like if we want to have some global money with some good security ratio, it will cost us like really a lot of resources. And the Ethereum coming from like the cypherpunk kind of environmentally or socially aware community was from the beginning was aware that there needs to be some solution. And it's not just the ecological part. I mean it's one of the things, but I will explain the more further. The one is security, that we can actually have a better, cheaper security. We can have, it enables us some scaling solutions, which enable to lower the fees in the long run. But like also you mentioned it, or like this was discussed early. But like the ecological impact of the proof of work was like literally one of the first 10 answers to in the mailing list when Satoshi posted Bitcoin, and it was Gilmore. It was John Gilmore who asked like that this is not scalable because like it will take so much energy to keep it running, right? So I mean it's not a new thing. This is one of the ways how to solve it, how to make it more effective, and at the same time achieve more security. So what is actually happening here is that like in the proof of work, the security which you the security margin, or the punishment for the miners is that they lose the profit. So if they misbehave, if they don't follow the correct chain and they just waste their energy, it costs them well the profit they would get. So the carrot that we have to motivate them. On the other hand, in the proof of stake security, we have not just the profit we can take from them, the carrot, but we also have a stake. So now, if they misbehave, we can beat them. And there is a slushing mechanism, and there is a leakage mechanism for stakers, which are acting against the network. And it means that basically, in a case that they are trying to attack, they will lose part of their stake, and if they continue to attack, they will lose all of it. So like now imagine for gamers, I compare it to spawn killing, right? Like somebody you just camp on the spawn, and yeah, here you go, and you're dead in a minute. So like now the misbehaving validator comes, and he's just being slashed over again, and he can lose all of his stake, and the attack gets very costly. So like if you imagine there is over $20 billion in the network right now, and half of it, let's say just 10, or if there is external actor and he wants to buy ETH and get in and create new validators, it would cost him even more. The price of ETH goes up, and now with the attack, he would just throw away all that money. He would literally burn it and just get destroyed, and it's very expensive to do this attack. So this is the kind of the security benefit we have. And talking about the security or the value secured here, it's good to realize like what we are at, because currently this is a screenshot from like 2 days ago. But with the prices around this time, the Ethereum network is securing 0.41 trillion. So like you have the capitalization, the market cap, yeah. So it's just the current price of the asset times how many units there are. And in Bitcoin, the market cap is under the $400 billion. But just the Bitcoin, right? I mean, the Bitcoin network has only Bitcoin on it. Let's say they are actually some other assets. There are some colored coins, there are some tokens, there are even some NFTs, but like it's marginal. In Ethereum, it's the ETH is just part of the network. The ETH is just the native token, but there are many other fungible and non-fungible tokens, which together, if we if we count this value, it's more than $400 billion, which is more than Bitcoin. Or around this time, the Ethereum network is securing bigger value than Bitcoin. So it's actually the biggest value secured or one network in the crypto ecosystem. Of course, I mean, there are some tokens which are derivatives of other tokens, and they are not really cannot be really sold for its price. So like the real number, or like the NFTs, right? I mean, the real number should be maybe slightly lower, but I mean, let's say it's around the same value, which I mean, it's crazy to imagine that we are now moving all of this value is just going to switch its security from one mechanism to another. We literally hot swapped, and that's exciting. And what we need to realize is also that now the biggest value till now, the biggest value, the Ethereum and Bitcoin together, the biggest value in the crypto space, almost $1 trillion altogether, depending on the price, was secured by the proof of work. But now the proof of stake is the one leading the total value secured. And to some other issues with proof of work, which the community have, is that like it's they call it proof of waste. this is from just I think just some flooding in China, but I don't really want to talk about whether it's waste or not. The important part here is that we are aiming for censorship resistance for decentralization, and now it's not that I'm not sure what is more trivial or what is easier, right? Whether to find this huge container which is super loud and pretty warm and just taking so much electricity, right? I mean, there are literally these cases when police raided someone's house because they thought they are growing weed, but because of the electricity consumption, but they were mining Bitcoin or some crypto. So like you have the actual censorship resistance of the proof of work is can be a bit fragile, and it costs a lot to transfer it. Like, so here is another example from Malaysia where the government seized illegal mining farm and just used a steamroller and destroyed all the miners. And the point here is that, like, with my validator, if I'm running the proof of stake validator on Ethereum now, I can, and it's running on a server in a country where it becomes illegal, or they want to seize it, or whatever. In a few minutes, the validator will be running on a different computer on a different part of the world. So it's very easy to transfer. It doesn't cost anything, basically. And to transfer the whole set of miners and find some other cheap source of electricity, it's, well, almost impossible. So there are people who did it. There are successful stories, especially with the latest China ban. I heard stories about like somebody moving the whole containers of miners elsewhere, and it makes sense because you want to save the machines, but it's just so costly, especially for normal people, right? So now the censorship resistance, I believe, can be improved when it's easier to handle the validators. And we are getting to the discussions like what is better, what not. And to me, I mean, it's various trade-offs. There are some arguments for some reasons why some benefits of the proof of stake, some benefits of the proof of work, and we can have this infinite discussion like what is better, what is worse. And I don't want to get into it. What I want to explain is that these are the visions of how I see it is actually a clash of visions. Like the Ethereum and the Bitcoin community has different visions. It's trying to achieve something a bit different. And now the Ethereum community just decides that this is a better tool for achieving what we want. And well, they're not forcing anybody else to change or whatnot. It's just like the conscious decision of the community, which has been there, as you said, since the beginning. So like it's more of a vision thing than like pure technical discussion at this point, I would say. Another thing of the proof of stake is that it enables us to have kind of cheaper security. So What does it mean is the kind of bullish case for the merge, somebody calls it, or like bankless, or somebody call it like that. But the point here is that the current inflation of Ethereum is something like 5.5 million ETH. Like this many ETH units of Ether are just created out of thin air for the miners each year. So the supply is growing, and on the other hand, we are burning fees since like a year ago, since the EIP 1559. We have a mechanism which, with each transaction, burns most of its fee. The fee that you pay for transactions, a part goes to the miner, but most of it just disappears from existence. So if we have higher fees and more transactions, it actually it can actually wait out the supply growth, and we have deflationary or like zero inflation Ethereum. But the thing is that, like, for example, these days, this is from like 2 days back, and the fees these days are very low. There is not many transactions, not many people are competing to get to the chain, as it was like a year ago when one Uniswap trade was like $200, for example. So now it's very cheap to use Ethereum, and also the per rate is very low, and that means that the inflation stays high. But with the merge, this is the same numbers, but after the merge, or if the merge was already happening now, the issuance for the new Ether for the validators is actually much lower than for the miners. So the inflation will go down, and with the burn rate being around, even with this low fees being the same or just a bit higher, we are at zero zero inflation of Ether, or even being deflationary. So people call it ultrasound money, whatnot. I mean, I don't really care about like whether this drives price or not. The price is not the point here. The point is that we have a sustainable network, in a sense that we don't need to count on either like infinite inflation or having being dependent fully on the fees to sustain the security of the network, right? So that's the technical point for this case here, and it's interesting to imagine like here's a protection with some values. From the Ultrasound Money website, they have a nice tool for that, so you can see that like if we have issuance, if we have 17.3 million Ether staked for next 80 years and the same burn rate, there will be only around 60 million, like half of the current supply will be there in 80 years. So it's crazy to imagine that there will be, even at one point, there will be probably even less Ether than there was at the creation of Ethereum, right? So yeah, so this is what is happening. But where's the scalability? Where are the hundreds and millions of transactions per second that we are hoping for? And well, this is the point of the gas fees. Even they are a bit low these days. Generally, the Ethereum has a scalability problem. There is only that amount of transactions we can fit into the chain, and this is because of the scalability trilemma. Because the chains like Bitcoin or Ethereum are focusing on being decentralized and secure. They set these arbitrary limits to how many transactions or how much data can be or execution can happen in one block, and this basically limits the size, the how heavy it is to verify all the data. So thanks to these limits, currently on my laptop, I can verify all the history, cryptographically verify and trustlessly use everything on Ethereum or Bitcoin. And this means that everybody can stake at home, can run their node, can verify it by themselves, use the network privately, and so on. Or it's very, very cheap to do that. If we remove these arbitrary limits, it means the fees might stay lower, but the cost of running the node would go up exponentially. So we cannot really, if we want to stay this censorship resistant, we cannot really afford that. So so we need to figure out some clever way how to achieve scalability, and at the same time being able to verify everything easily. So the original vision was the sharding, and the current vision still is, but like some details change along the way. And sharding is as you can see before, it was one of the visions, one of the steps, one of the phases in the original like E2 idea. And it's something which is actually enabled by the proof of stake. So what is it is that instead of having like one data layer, we enforce, or you have one coordination, a chain, the beacon chain, which is enforcing data availability and verifying data from multiple shard chains, from the multiple data layers. And this enables us to, with like one normal computer, to verify a lot of data from all these shards, and therefore it can scale exponentially. It can scale really nice. So the current specification, or the current vision of the sharding is called Dank sharding, which is created by Dankert Feist, and it works with the random sampling. It uses samples, random parts of data from the shard chains, and with the Reed-Solomon code, which is a code used similar like in DVDs, like you have some missing part of data, but you're able to compute the rest of data because of polynomials. So with the random sampling and the Reed-Solomon, it's able to verify with a single computer, or like simple machine. You can verify a lot of data from various shards. So this is the long-term vision, and it's getting specified. It's getting implemented. As you can see, here is in the consensus specs is but it's I think it's even more progress right now, so you can check it out. But meanwhile, we have layer 2s, we have rollups on Ethereum, and the rollups are actually part of this vision. There is a so-called proto-dank sharding proposal created by Proto-Lambda, and what is this proposal is that it takes the data, it creates a new kind of transaction which takes the data, the rollup data can be published into the beacon chain and handled there with KZG commitments instead of being directly in the state in the EVM execution right now. So the EVM doesn't execute anything. It's much cheaper to store the data like this, and it's something which is compatible with the dank sharding. It's something which is later the dank sharding can be built on. So basically, you can imagine that the current rollups will become shards later, and their usage will be even more effective. It will become even cheaper to use. So yeah, this is how it looks like, right? Now we have the sharded state instead of just the plain state. We have the data availability in many layers, and it's also execution. So that's why there are the two arrows, and this is what I call Ethereum. This whole thing is Ethereum. And there is no Ethereum 2.0. It's still just changing various parts and improving various parts of these modules to create something which is more scalable, more secure, and yeah. So that's kind of my point there. The terms that we used before, like E2 and E1, are deprecated. We can imagine it now like the implementation of what was the E2, the proof of stake is the consensus layer now, and as it merges with the black bear, with the execution layer, it becomes the panda, the Ethereum. So that's why the panda is kind of the symbol of the merge, and yeah. So this is how it looks like in practice. You saw before I showed a picture of the happy developers clapping, Vitalik excited about seeing the merge. This is what I saw. As you can see, it's 8th of October last year, and it just says entered proof of stake stage. That's pretty boring. log, right? So now we have cooler logs. Now we have pandas, and this is what you can see as well if you would like to contribute. So here are some ideas how to contribute to the merge, or some first of all, how it's actually tested, and how we are avoiding some unknowns. Yeah, so we are fuzzing and stress testing the network. There is basically a lot of transactions which can result, various types of transactions, some of which can result some edge cases, and the fuzzer is spamming the network with these transactions, spamming the clients, trying to find some edge case which will trigger wrong state transition, right? The very interesting way of the test client, the merge testing is shadow forks. And what shadow forks are doing is that basically they take a few nodes from the network, from the main before Garly, but also now the mainnet. Some mainnet validators are merged as they go through the merge, as it's going to happen, and we see whether it goes smooth or not, right? So in this case, it was a shadow fork like months ago. Now there was like I'm sure how many, like 20 of them maybe, or less. The last one is these days before the merge, and here you can see that like 4 of those validators went down for some reason, and that's one way of testing. And then there is Hive, which is very nice tool, like a harness which enables various client combinations, various runs them through various test scenarios. And how can you actually contribute here? So if you are just a beginner, you can do what you're doing now, learn about the merge, and educate further, answer some questions if somebody will be confused about what is actually happening. There is Kiln testnet, which will be deprecated soon. It will be deprecated when the merge happens, but it's the official merge testnet. There is also Sepolia and Gerli, which are the which will be the long-term maintained testnets, which are currently all merged, and you can try, if you're a dApp developer, you can try your contracts there, or just as a user, you can try to use it for MetaMask. You can run the node, and you can see how the network looks like after the merge. You can run a validator on Kiln or Gerli, which means that you get the tested Ether, you stake it, and you actually validate in the network. And while you're doing this, you need to do all the staking. You need to run your own node, some client combination, and this gives you, this forces you to read the documentation. And you might also notice some issues with the documentation, something which is not explained properly. So you can just contribute and fix it for them. So that's another way how to contribute. Then you can also and just run various client combinations, visualize the metrics with Grafana, and figure out whether everything works well. And yeah, if you are more advanced, I mean, there is the way how to debug the clients, to actually look into the code. These are like more beginner advices, but if you are more technical, you can become friends with core devs. That's my message here. And this is pretty important. This is pretty cool stuff. So if you are a technical student, or just like you like to code, you like Ethereum or some blockchain technologies, and you would like to work on the protocol, check out the Ethereum Protocol Fellowship. You can just find the Protocol Fellowship, Ethereum Protocol Fellowship, on this blog.ethereum.org, where you can find all the details. And this is basically a fellowship program which where you can apply and work on some core protocol project directly with the current core developers. You can get mentorship of some core developers, and just learn how to work on the protocol itself. And those things I talked about, or those things from the long-term Ethereum roadmap which need to be solved, you can work on those. If there is any area which excites you, this is a great opportunity to tackle it. So yeah, the Protocol Fellowship, check it out. And some people, there are just a few of them I have here to follow. If you are if you want to know like who is behind this merge thing. So yeah, I mentioned the testing before. Like that's Marius and Mario on the left here. Marius is running the fuzzer. Mario is working on Hive. Paritosh is the validator whisperer. Yeah, he's running those shadow forks I mentioned. Danny Ryan and Sherwink are leading. Showway and Danny are leaders of the Ethereum R&D, or like the research team in Ethereum Foundation, and they were focused on specifying the consensus. Tim is running the all core devs calls. So if you ever follow the core developers, you might notice these calls, which happen every 2 weeks, and almost everybody who is involved in the core development is here, expressing their opinions on various current problematics. So you can check all the streams from these on YouTube. You can also join through Ethereum R&D Discord if you have something to discuss. If you actually work on some core project, if you, for example, join the fellowship. And yeah, so there are also people like here I see Potus, Paul, Light Clan, who are working on, or here Terence and Lion and Paul, who are working on the client implementations themselves, who are implementing the merge in the consensus and the execution clients. So what are the consensus and execution clients? I mentioned before the current, or like the Ethereum clients, but the implementation of the proof of stake, the consensus, is in another client, in another piece of software, and that's Prism, Lighthouse, Teku, Nimbus, and also Lodestar is like battle ready, production ready, and these are provide the consensus part. So if you are running the node, if you are actually using the Ethereum, you're using some execution engine, some current client, like I showed before, the Go Ethereum, Besu, Nethermind, connected to one of these, which drives the consensus. And yeah, those are people working on them. If you want to stake, if you want to become actually the validator in the network, you can find more info on the launchpad.ethereum.org. And this is something which requires you to run this client on some stable machine, and it requires you to stake 32 ETH. And but there are the staking pools like Rocket Pool, which enables doing this just with 16 ETH, actually. So you can also run your own node and with just half of the liquidity. This is how the deposits, like these are individual depositors to the deposit contract. It means that like you can see that some of them are even one entity. So like the thing is that just few entities have like 40-50% of the network, which is not that good for decentralization. So if you are running your own validator, you are taking power from these big entities. And yeah, regarding the client diversity, which I talked about in the beginning, you can see the current status here. So in the consensus clients, we have pretty nice diversity. And if you are thinking about running your own nodes through the merge, or even staking, consider Teku or Nimbus or Lodestar. And for the execution, try to avoid GAT. So like you see, there is a biggest dominance with the Go Ethereum client. Yeah, so basically that's what's happening. That people just go with some easiest option, or like what was their first, what the tutorials mentioned the most, and then the client diversity suffers. But and even the website even shows there like the various colors. So like if there is the client has less than 30% or less than third of the network, basically it cannot harm if there is some issue with the client. Yeah, so here we are. We have all these cool features that it's not E2, it's just Ethereum. And why it's not E2, or like why there is, I wouldn't say there is some stage, because it's the Ethereum. I see it as an infinite game or infinite garden. It's still, there is always something to do, and with the new solutions, there are new problems, and this is the roadmap which Vitalik put together like in December last year, I think. And you see many boxes here. They are happening in parallel. So there is the merge, the surge, the verge, the purge, and the splurge. I love the names. And the merge is basically done. Like yeah. So what we are missing here is the post-merge hard fork and like single slot finality in the long-term extras and improved signature aggregations and stuff like this. But there are other interesting things you can work on, or like the current researchers and developers are looking at, and that's the sharding, which I mentioned, or the surge. The verge, which is Merkle trees, it enables vector commitment Merkle trees, which is a different database structure. And this one should also enables us better state expiry or history expiry, uh, which is another thing which has to be solved to have some alternative history access, and being able to basically to be basically able to run the node like just the latest data. Yeah, and then just other like MEV stuff, proposed boulder separation, which is happening on the protocol level, and yeah, the EVM improvements and so on. So there is a lot of things which are happening on Ethereum, and to understand like what is Ethereum, I say it's a concept of the execution, everything else, all these things around it, and it's all still Ethereum. There is no Ethereum 2. I hate when like Coinbase did this and they confused so many people that there is some E2 friggin' token, which is not possible. So so yeah, don't think that something like this will happen. And to sum it up, there is no E2, there is no E2 token. Don't expect downtime. To be precise, like, so when the merge happens, as I said, like the ideal case, you just send transactions, you don't even notice that something happens. It will be smooth. There will be just next block. But this in the proof of stake stage, we are waiting for this block to be finalized. So like after two epochs, after like 13 minutes, the network, the validators have to vote to, or they're doing attestation to create a weak subjectivity checkpoint, which is a fully finalized block. It means that the epoch, the block, which is after the merge, is considered by all the validators as immutable. In this moment, when the finalization is reached, we can say that the merge was successful and the network just keeps growing, keep running. During these 30 minutes, people will sweat. It might be scary, but once the finalization is reached, everything is done. Don't expect the fees to get cheaper, because currently there is no scalability improvement in the merge. But the merge with the proof of stake with the beacon chain enables us to create proto-dunk sharding and dunk sharding and other scalability improvements in the future. To run a node, if you want to use Ethereum trustlessly, securely, privately, you don't need anything. You just can run it on your computer, and it doesn't. The stake, the theory to eat, is only required if you want to run the validator to actually validate, to get some profit and become the validator. But you can just run the node as it is now. And the most important question: when is it actually happening? So yeah, the timing. So as I said, the Ethereum, the merge is timed based on the total difficulty in the network. What does it mean? It's basically the each block has a certain difficulty. It measures how many hashes is needed to guess the right number to solve the proof of work. And if you stack this up, you have the total difficulty in the network. And this um, this number is big, as you can see here. And when the certain total difficulty, accumulated difficulty network is reached, the merge happens. So the clients, since now, like for the past few days already, they are waiting for the network to reach this total terminal difficulty number. And when it happens, the merge happens, right? So where can you track this is Bordel.wtf, which creates a regression to predict when is it going to happen, and it's solely based on the hash rate. Like if the miners continue to mine at the same pace, it will happen like in less than a week, in like September 14 evening, September 15 morning. um, and of course, if it can happen a bit later or even faster if the hash rate changes. But this is where you can wait for the merge. So yeah, that's it. Thank you so much for listening. Before I finish, I'd like to invite you for some events for the Bordel merge party. So this Bordel website is actually named uh, uh, based on the Bordel hackerspace, which is in Paralelnipolis in Prague, the place that the folks were mentioning, where we met at ETH Prague. And now in the hackerspace, we are organizing a party. It will be cool. It will be fancy. It will be a huge celebration of the merge. And you can come to visit physically or even online at bordel.world. More info is at bordel.wtf. You can find a link there. And I would like to invite you to Hackers Congress Paralelnipolis, which is a conference we organize in this place. It's a similar vibe to ETH Prague, actually, but focused on generally like cypherpunk, crypto anarchy, digital freedom, art, science, and part of it is Ethereum. But there are many other interesting things, technical or non-technical topics that you can learn about. So check out hcpp.cz, or just feel free to reach out to me. I might be able to get you some discounted tickets or something. Feel free to reach out. So yeah, that's it. Thank you so much again for having me. Thank you so much for listening. And I guess I'm open for questions right now. You can also, yeah.
Thank you for everything. It was a really good information for us, and thank you for the invitations to Bordel. I first want to. We know very well what's maybe the people who are watching don't know. What is Bordel? What does Bordel mean for you? We can start like, and I think we didn't talk about what is your technical background. What did you do before joining Ethereum Foundation, and what do you do now?
Right. So yeah, what is Bordel? It's my Bordel is my or our kind of baby project. It's so the story goes like with the Paralelnipolis. So Paralelnipolis is this unique space in Prague. It's actually, let me show you. It will be the because I. See, let me show you what is it. So I can show you some links directly if you can see my browser. So Paralelnipolis is this black building in Prague, and for past 8 years it's been running, spreading the crypto anarchy, accepting only crypto in the cafe, in the co-working, and in the Insta crypto anarchy. And then there is the basement, and the basement of this beautiful building was always a mess. It was just used as storage, and sometimes they try to clean it, do some events there. There were some 3D printing workshops and so on, but it never got a concept, and they just put stuff there and they used the storage, which is really wasteful to have such a beautiful building and use it for storage, because you can just get a garage somewhere. And that's what we did. We got a cheap storage in a garage, and we turned this basement into a hackerspace called Bordel. And the Bordel means MS. Bordel means chaos. And yeah, this is how it looked like with the fans. There were so many fans for some reason, and we were just moving them and took the picture. So it's a low-key joke, are you a fan? And and this website, you can learn a bit more about it. When you're coming to Prague, feel free to visit. And this is the actual technical part where we have workshops, but also parties, like a modular space, which enables us to work with hardware, with 3D printers, I don't know, soldering, whatnot. And we run servers there, but also we have nice light setup and we can do parties there. Yeah, and the part I mentioned. So if you go here, you have the link here or here, and this is the invitation for the party. So it's happening Sunday, September 18, in less than 2 weeks, right? And here is the registration form. So that's and the HCPP conference, which I mentioned before. It's this one. Many like this ninth already. So 8 of them already happened. There are many interesting speakers from all around the world who visited us during the years. And for the current year, the topic is last shot. And there are many cool people who you can meet there, many interesting talks. Mitch Altman, who is kind of like, for me, was the biggest. He's a hacker, and he was the inspiration for me in the like hackerspace movement. I actually built a hackerspace. Ryan Leckie, Cypherpunk, Phil Zimmerman, the creator of PGP, uh, Eric Silverlane, known in the Bitcoin community, Brewster, who is the creator of Internet Archive, which you might use many times, right? A bunch of folks from DarkFi, and yeah, so this is the Congress. Feel free to come and let me know if you would like to participate somehow. And I wrote about my background. So basically, what should I say about me? Yeah, I was involved in these communities since I was like 15, 16, and then I went to university. I dropped out after less than 2 years. I studied computer science, and I was focused on security and stuff. And but meanwhile, I started to work more technically in the Bitcoin projects, in Ethereum stuff, do some research, and then I just decided it doesn't make sense for me anymore to study there because I learn more in the research that I do then, um, and school, right? So yeah, that's my background basically. I've been literally living for some part for some weeks in this building, just getting knowing the people, the energy, learning so much from the community, and yeah, conferences, hackathons. Yeah, that's my background.
Thank you. Everyone should see and experience Parallel and Bordal, I think. Also, there were some pops. I could mint one, and I think there are more remaining ones. You should claim some Bordal pops. Just an announcement for participants.
Yeah, thank you so much. There is like last few of them. So with the Supervis, who is from the Eat Staker community, he did a huge help. He basically set up the whole thing, and we created this pop for everybody who loves the Portal WTF predictions. And if you come to the party during the Portal merch party, and you have the pop, you get a special prize, special gift. So show up with your pop in Portal.
I'm sure that the merch party in the Prague will be an absolutely amazing due to my experience. The party in the Prague will be a very good. Thanks a lot for your presentation. So, what if you wish, we can start to ask our and the community's questions more about in merch. What if it's okay? I can start. I think that is there any simulation as now of that can test the Ethereum mainnet merge in real time? For example, that can be like EVM fork has a thousand of clients nodes, trying to do the merge. Is there any simulation like this to before the merge, to see the station of the
So yeah, there are the, as I explained before, there are the shadow forks, which is basically this, like merging parts of the existing network, and there is currently 13.1 happening soon, or already happened. Let me see. It's in it clients merge testnets repo. I can share the link here if you can somehow share it in the stream. So here you can learn about the various testnets that happened, which were intended to test the merge, and then there is Hive, which creates like a local testnet and tests the client. So it's basically, yeah, it's a very versatile tool. And I also send the link here, so we can look into these. If you would like to contribute to Hive, if you would like to help with the protocol, like that's there is a lot of work on this one. There's many things which can be done there, and Mario Vega is working on it. He's a really great testing contributor. He can mentor you during the fellowship call if you're interested. Yeah. So yeah, you can see the latest shadow forks is the 13 there.
And also, what kind of dangers await us after the merge? Is there any? It can be any censorship after the merge because of the stakes amount, large of the stakes amounts in the central organizations.
Yeah, so like this is something which was recently discussed mostly on Twitter, I would say, and also in the all core devs like 2 weeks ago there was a great discussion on that. I recommend that, but generally, like I would say, yeah, there is a threat of censorship. To compare it but like what we need to realize that it's not that different to current situation. Currently, if there is miner who has like vast majority of network, more than 50%, let's say like 70 or something, which is the problematic threshold even in the proof of stake. If somebody has so much money, so much power there, what he can do is just mine his own censored chain, which will have more work, more difficulty accumulated, and that means that node naively would follow this miners, even if they're censoring something. They're just soft forking, basically. They are just ignoring transactions and not breaking any rules. In case of the proof of stake after the merge situation, we see similar scenario where somebody who has most of the stake could just not include any transactions. The difference here is that individual stakers have much more power. If you are running your validator at home, you can be sure at one point you will be picked to propose a new block. That means you build the whole block, you send it to the network, and you build it by yourself. In case you are mining, if you have graphic cards or some ASIC at home, or warming your stuff during the winter, you are just given part, like some work share by the pool. So you're just the pool node is the one which constructs the block, and you don't have any right to say what is in the block. In the proof of stake, as an individual validator, you have this buffer. But well, let's say the individual validators are such a tiny majority that it becomes a problem. So now there are two situations. One is that because of big part of the network not attesting non-compliant blocks, let's say, there would be leakage. There would be basically a punishment for the validators who are not active, to the point where they would be basically not able to, or like they would be removed from the validator pool, and the network would finalize itself with those who are attesting correctly. And in a case that really like 90% or like everybody just tries to do censorship, the only thing the community can do is soft work, user activated soft work. So there is also always the social recovery cost. And some people think that like this is something which is automatic in the proof of work, but like as I said before, like it can happen that there is a big chain, and your node will just blindly follow what is the strongest. And same, there's Gasper or LMD Ghost in Ethereum, and that's the fork trace rule. And now this rule can put us on a chain which is censoring, but we can decide to go to another one basically, and remove the stake. And like the point is like this is like edgy scenario, but what I think is that in this case, all of these means that there is a huge punishment for those who are censoring the blocks, and that means that trying to censor the blocks would cost you so much money, or there is a risk that it will cost you so much money. There is some chance that you will be successful, but there is a high risk that you will lose your stake. And especially the institutional stakers, especially those who are like, I don't know, Coinbase or whatnot, who are holding someone else's money, cannot afford this. They wouldn't risk someone else's money which they are custodian of. So I would say that this risk that they would have to go through is what is keeping them apart. Yeah. So yeah, basically that's that on censorship.
My question is it possible to prove a censorship mathematically? I saw a concept called client fingerprints, which detects the behaviors of the clients, and it might be detecting some censorship attempts, but I'm not sure is it possible mathematically and prove. So
Yeah.
it might be possible to slash as a social fork who is censoring.
So yeah, it gets complicated. So first of all, like it's not really slashing. What we are doing is the leakage. It's the inactivity leak, which is the punishment for the people who are not attesting the non-compliant blocks. And but we do it just because because it's the normal rules. And now whether there is a way how to identify the censorship, well, it's a bit complicated, because like on one hand you can predict how the next block is supposed to look like. Yeah, you take the current transactions and you say, okay, these transactions will be in the next block, or should be most of them. And if you see the difference here, you can say that, okay, he's censoring. You can see that these are not being added to the blocks. Okay, let's say we could somehow enforce on that, but it gets dangerous. It's not really possible, and especially because of MEV. So the MEV is like a side channel through which uh, 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 the people who want to do some value extraction communicate directly through the side channel to miners or to stakers, and they can get their transactions included even if they are not in the mempool. So we can see weird ordering of transactions, and Etherscan is detecting this. There's also a way how to detect this. So we already detect this, but basically to be able to figure out like what is just MEV, what is censorship, and to put this together, like it's not really possible on the protocol in the current state. Like with the protocol builder, the separation with the PBS, which is basically this EVM tool, the MEV tooling baked directly in the protocol. Hopefully, at that point, we will have like a clear specification of how to enforce the resistance there. Yeah.
Thank you so much. I want to say something about the Bellatrix updates. I read that there are still clients that change between the 25% of the total clients hasn't update their clients. So what clients are these? Why don't people update their client yet? All of these are just minors, or the what else? What do you think about it?
So like with the Bellatrix, which happened on Tuesday, like well 2 days ago, we can see the participation clearly. So there are two things. There are the validating nodes, and there are just the nodes in the network. It's really hard with the validating nodes. We can see clearly like what validators are participating. because we see there is validator, and now he just after Bellatrix he's just quiet, so he probably didn't update it, or I don't know, maybe power went out or something. But like we saw that like 4 or 5% of the validators went down after the Bellatrix, which is really good. It went from 99.5% to like 95% participation rate, which is really well. And after a few hours, it recovered to like 98%, and it's recovering since then. So we see that the validators who are actually, they have the money on stake, right? They don't want to lose money, they want to make the profit, so they are forced, or they are conscious about updating their nodes. And generally the nodes in the network, it's not easy to determine because it's a distributed network, and there is thousands or possibly tens of thousands of these nodes, and to crawl them it takes a while, and not everybody, not all the nodes let them crawl you, right? So like the crawling means you just try to ask everybody, hey, what client version you have, are you ready for the merge? And some of them just don't answer because they have enough peers, and they're not willing to answer. So it's not easy to determine like the whole number. There is the Ether nodes, there is crawler Ethereum.org, so at least like few projects which are trying to achieve this, but we never have like 100% view of the network, of like how many nodes are ready for the merge. But again, like being the validator, if I'm validator or if I'm running the service, so something which is important, something which people depend on or the money depend on, I will update, because like, I mean, I have to, right? and if not, I mean, or like if I believe that the majority with the Bellatrix, we saw that the vast majority updated. So like there shouldn't be. I don't expect there will be such a difference with the Paris.
Thank you so much for your answer.
And what do you think about a proof of work using fork after the merge? Does a proof of work Ether can get any value from the community, or
So I
is it
mean,
just
there is. I mean, that there are some people who want to run the proof of work chain, right? Because I mean, it kind of makes sense that there is some part, like, so like the beautiful thing is that the majority, like the 99% of the community, like all the dApps I can think of, all the infrastructure, everybody who is in the Ethereum for some time, for more than a week, understands like, or like is ready for the merge, for the proof of stake for some time now. And there are people who oppose to it, mostly some miners, I guess, who will lose the profit. So I understand that there is somebody who is trying to create his own thing, but it's dangerous. Like it's I don't think that like with all the developers and all the community being here, like there is just, I can't imagine like what developer power there can be to create something which is comparable, or just on level close to where the Ethereum is. Yeah.
Maybe that can be a little personal question, but when we met with you at ETH Barcelona, you were dealing with the merge of the Sequoia test chain with your computer on your lap, and you are looking through the many hashes or the complicated things. So, for example, what were you doing at that time? Can
During
you give
ETH
a little
Barcelona,
more
yeah.
detail on how merge testing works? You are looking through the
Yeah.
that's equivalent hashes, or what was that?
So yeah. So the Sepolia merge happened during the ETH Barcelona Ropsten merge, which was the long running testnet. The merge on Ropsten happened in like few like days, like 2 days before ETH Prague.
Each track, yeah.
And so my role in the big scheme of things was to mine it, basically. So as I said before, like the merge is activated and a certain total difficulty accumulated in the network, right? So the goal is to accumulate this difficulty. And what I did is I created the prediction engine, or like the prediction tool, which takes current data and tells you when that amount of difficulty will be accumulated. So we can estimate when the merge should happen on the testnets and now the mainnet. And with the Sepolia, or like with the Ropsten first, what we did, or what I did, is I took the current data and I estimated, okay, so with the current hash rate, or like the with the extrapolating, projecting the past few weeks of data, the merge should have, if we want the merge happen to if we want merge to happen in like 2 weeks, it should be this value. And the hash rate was like to a few hundred mega hashes. And when we announced it, a few days later, somebody put like tens of gigahash, like hundreds times more mining power on the Ropsten network, and it reached the point of the merge in like a day or like in a few hours, which was ridiculous. So then we realized like we cannot we have to protect from these attacks. We cannot just wait for some miner who has spare. I mean, it costs like a few $100 to do it because the testnet hash rate is super low and there is just some volunteers mining it basically. So what we did is we set the total difficulty, the terminal difficulty, the TTD for the merge much higher. So it cannot even be reached with the normal with the normal hash rate in the network, and we mine it by ourselves. So, and I was the one mining it. So I calculate in for each minute, I calculate like how much hash rate is needed in the network. You can see it in the Borel WTF even now. I create the predictions, and I'm putting the hash rate to the network. So I was renting a bunch of rigs, and I was coordinating them and correcting the values, so it happens at a time that we plan. During the Ropsten merge with the Get team, we gathered in the Bordel. There was a bunch of memes about it, and there was the Eat Staker call, and it got a bit stretched because there was issue with the mining pool and the rigs, and it took like hour something, or like less than 2 hours more than we expected. But we get there like with a 2 hours difference. And then during ETH Barcelona with the Sepolia merge, I get this experience. So I handled the miners and the pools with some improved techniques, and I managed to merge it like with 2 minute difference. So like 2 hours, 2 minutes, like it's much better. So I was trying to make sure that the Sepolia merge will happen exactly at the time that everybody expects, and there was also like Eat Staker call, so the community, the developers are waiting for it, and I want it to happen exactly on time. So I was the one mining it and trying to get there right on the time. And yeah, and then with this experience, I predicted, or like I created the estimation for the mainnet TTD. So yeah, that is the one when it's happening.
I see. Also, in Turkey, when people want something to be great, they promise something. For example, if my exam goes well, I will buy you a meal, like that. Is there anything you want to do if merge is successful?
Well, I mean, I should do that, right? I mean, I should do some, I should do some stakes. I think we have all enough staked in this to just wish it goes well already. Yeah. Yeah, but I mean, come on, like we party, we have the bottle party if it goes well. So like, even if it doesn't, we'll just party, but less hard because there is still work to do.
Are there any risks that you're afraid on the merge?
Yeah, I mean, so like, there is a great talk by Danny Ryan from Amsterdam, I think, from the Securium event. I think it was there, about like the risks of the merge, and there are like many bugs which can occur of various severity. And but personally, I'm not sure whether I should be afraid of something specific. I mean, yeah, what we discussed before, like people don't update, or like they update, but the mess up the configuration in some way, and the most of the network won't finalize or something like that. that wouldn't be nice. Yeah. Uh, but yeah, nothing more specific. Yeah. Can we do like last question? Maybe it's getting stretched a bit. I have to run for food soon.
And I think three of us have applied for the protocol fellowship. I hope
Wow,
to.
nice, nice, awesome.
I think that people from our community will take a chance to and apply to contribute the future of the Ethereum. Maybe more
Awesome,
and more
awesome.
people try to apply the fellowship. Uh, Maybe we can share the links of the apply
Yeah,
form
yeah.
to our
Please
community.
share
That
the
will
blog
be
post
increase the
and yeah.
application fellowship. Yeah,
Totally,
that's
please share the blog post. And like, what I want to say is that so some people like there is hundreds of people applying, and only like 10, 20, like small number will get picked. And these people who are picked have like the there is no difference if you want to contribute and you were not picked to get the funding or the mentorship, because you still can contribute. You can just go to the repo. There is a link to that repo in the blog post, and there you can see everybody's creating their notes, suggesting projects, so you can just start to work on some project by yourself. And if you create some nice contributions later, you can actually join the program, or like even if you are okay with not receiving some funding, you can work on some project, and if it's valuable, some core devs will pick up on that, and you are becoming part of the community, right? So like feel free to if there is something you're excited about, just feel free to tackle it and work on it as a part of the EPF, even if you get like not rejected or whatever.
so maybe that can be a little speculative question, but um, what do you think about it? What do you think is the main reason why Ethereum merge was late so much? The main reason, just
I mean, I don't know. It's very subjective. Like, I mean, somebody would say it's late. Somebody would say it's soon. Somebody was saying it will happen later. I mean, there were even the core community has some expectations earlier, but it is there. It's the common fallacy that you just expect something to be done earlier than it's possible, and I think it happening right on time. It's happening when it's ready, right? So like there was a lot of testing, a lot of research happening around it for past years, and and I mean it's just, well, the issues you run into and the improvements you need to do and the more testing you need to figure out, which just takes on. And yeah.
thank you so much again. It was a really good interview or the presentation. Thanks so much, Mario, for answering all of our questions. That will be so meaningful for our communities, our friends, our technical students, or what you think that. So at these days, I want to mention more about DevCon Istanbul. We tried to do DevCon 7 in the Istanbul. The proposal has going to more prominent the other the proposal, but maybe what if you can take a chance to contribute more over the Ethereum Foundation community? That would be
Yeah, I
good.
need to come to DevCon forum and give my 2 cents there. Like, I definitely like it. Like, I think Istanbul is a nice place. So, I mean, there are many factors to it, but I know I saw it on DevCon forum. I was reading it, but I didn't comment it yet. So I'll look into it for sure. Yeah, wish you luck with that. And again, thank you so much for having me. Thank you so much for giving me this opportunity to speak to all of you. And thank you for the great questions. I hope I gave you something valuable today and you enjoyed it. Yeah.
Very
Thanks so
nice to
much.
meet you again, and see you in Berlin, then Bogota, I think.
See you in
And
Bogota for sure. Yeah. Thank you so much, folks.
we are going to the Bogota, so maybe we can meet again.
Yeah, see you there.
Okay. Thanks so much again.
See you, everyone. Thank
See
you.
you.
Panda.